All right, in this video, what I want to do is I want to talk a little bit about Chapter 5 material. Chapter 5 is going to be about what are called random variables, and we'll talk about random variables and probability distributions. A random variable is, I actually hate the name random variable. It's not random and it's not a variable, it's a function. And it's a function depending on some experiment. So a function depending on an experiment. And I'll explain exactly what I mean by that with a few examples. So as our first example, let's say that we flip a coin. Let's say we flip just to make sure. We flip a fair coin 3 times. And so the coin it's got a side that's heads, a side that's tails. And so we have 2 to the 3 or 8 different possibilities. And so our 8 possibilities are our sample space. It could be all heads. It could be 2 heads and 1 tail. And there's 3 ways that that can happen. It can be 1 head and 2 tails. And there's 3 ways that that can happen. And then it could be all tails. So there's 8 possibilities here, 8 different outcomes. And what we could do is our random variable, we're going to denote by x. Sometimes I'll put a line above and below that x just to remind us that it's a capital X. But x, say, let's say that x is going to count, x counts the number of heads flipped. So in this example, x can take the value 0 through 3. So this can be either 0, 1, 2, or 3. And that's it. Those are the only possibilities that are allowed. So x can be equal to 0, 1, 2, or 3. And what we can do with that, and this is going to allow us to talk about distributions, which would be very helpful, is let's say I wanted to find the probability that a random variable is equal to 1. What that means is really we're just doing kind of a problem that we can already do. This is a chapter 4 problem. Find the probability that we flip exactly 1 head. So how do we do that? Well, we just have to count the number of ways that that can happen divided by the size of the sample space. And we've already said that the sample space has 8 elements in it. And now we just have to count how many different possibilities are there that have exactly 1 head. And there's 3. We have 1, 2, and 3. So those are the 3 places where we can have exactly 1 head. And so the probability that x is 1 is going to be 3. What this is going to allow us to do is it's going to allow us to make what's called a probability distribution. So this will allow us to form a probability distribution. And what that is it's going to be a table. And what the table is going to do, this, by the way, is actually called, I want to add one word here. This is called the discrete probability distribution. Discrete was one of the words that we talked about in chapter 1, but we didn't make too much of a fuss out of it. Discrete just means that the values that our random variable can take, we can write in a list. So their values 0, 1, 2, 3, and that's it. This is in contrast to a continuous random variable, which we'll talk about in chapter 6. So that's a problem for later. But a continuous random variable can take values in any range. So say any number between 0 and 3, including things like square root of 2, which is 1.41, whatever. So that's a continuous distribution. It can take any value you want in some range, whereas a discrete probability distribution is just a distribution where your outputs of the random variable you can write down in a list. So for us, it's 0, 1, 2, and 3. So we're going to deal with discrete random variables for now, and then continuous random variables later. So for the discrete probability distribution, what we're going to do is in the left column, we're going to put what are the outputs that a random variable can give, what are the outputs that it produces. And then on the right side, we'll talk about what's the probability that those outputs produce. And here, I apologize, I mean to write a small x. And so this is going to be the values. So small x is going to denote the values that our random variable can take. So our small x in this case was 1. And so our random variable can take the values 0 through 3. And then we want to count what's the probability that our random variable will be equal to that value x. And so we have to go through and we have to find the probability that we have 0 heads. And there's one way out of 8 that that can happen. So there's just one way that that can happen. Probability of 1 head, which we already found to be 3/8. Probability of 2 heads, which we can probably guess, or we can just count, is also 3/8, because there's 3 ways that that can happen. The size of the sample space is 3. And then the probability of 3 heads is 1/8. There's one way that that can happen. And again, the size of the sample space is 8. And this is our probability distribution. So this is a first example of a probability distribution.